Welcome back to first year geometry class. Today we are here to discuss about straight lines. One of the most important topic to study for physics as well as for trigonometry also. In this topic, we are going to discuss about the basic fundamentals. We discuss about the slope of a line and how the slope of a line can be calculated, definition of it, and slopes of parallel lines, slopes of perpendicular lines. Today, let us discuss about slope. The main concept of today's topic is slope of a line. Dear students, before discussing slope of a line, first all students must know about angle of inclination of a line. So what is meant by angle of inclination of a line? So let us discuss about angle of inclination of a line. Angle of inclination of a line. Before defining slope, one should know, or one must have correct idea of angle of inclination of a line. Once, if you are aware of angle of inclination of a line, it is very easy to define slope of a line. So let us start with angle of inclination of a line. Dear friends, so these are the two coordinate axes. This x-axis, y-axis, and this is the origin. If a straight line makes an angle theta with the positive x-axis, if a straight line makes an angle theta with the positive x-axis in positive direction and lies in the interval 0 to 180 degrees, then this angle theta is called angle of inclination of the line, or just call it as inclination of a line. So I repeat this sentence once again, I repeat this angle of inclination once again. Angle of inclination of the line. If a line makes an angle theta with the positive x-axis measured in positive direction, lies between the interval 0 to 180 degrees, here is 0 is included and 180 is not included, then angle theta is called angle of inclination of the line, or then theta is called simply inclination of the line. But here one thing you have to understand properly, the inclination of the line always lies between 0 to 180 degrees. For all horizontal lines, angle of inclination will be always 0 degrees. So let us once again come back to the final status. Angle of inclination of a line can be defined like this. Angle of inclination of a line is the angle of the line with the positive x-axis measured in positive direction, lies in the interval 0 to 180, where I have written this, lies in the interval 0 to 180 degrees, then the angle theta is going to be called as angle of inclination of the line. Once, if the angle of inclination of the line is confirmed, then we define slope or gradient. Slope or gradient, usually denoted by m. Slope or gradient of a straight line. Slope or gradient of a straight line. So here, dear friends, once again, here again we came to know this clearly. This line making an angle theta with the positive x-axis and measured in positive direction and lies in the interval 0 to 180, then this angle is going to be called as angle of inclination of the line. But always angle of inclination will be measured from the positive x-axis, and it will be from positive x-axis measured in positive direction. So let us again, dear students, we will discuss about now. Let us define slope of a straight line. Let us define slope of a straight line. So now slope or gradient of a straight line. Let us first consider this is a straight line. Clearly we are observing this line has inclination what? Theta. To define here the slope of any line, the slope is already, usually we know that slope of any line depends on opposite side and adjacent side. The slope of a line always depends on opposite side and adjacent side. Hence, to define slope, we always use the tan function or cot. So, tan and cot are reciprocals to each other. So, let us define a line whose inclination is theta. Then to find out slope of that line, tangent of inclination. Tangent of inclination of the line is called slope of a line. So let me once again define what is slope of a straight line. A line whose inclination is theta, then tangent of the inclination of that line is called slope of the line or gradient of the line. So let me write clear definition here. The slope of a straight line. So here once again this x-axis and y-axis as origin, a line whose inclination is theta, then slope of this line can be calculated by using tan of inclination of the line. Tan of inclination of the line. So usually slope is denoted by m and slope has no units, purely it is a real number. So finally we came to know that slope always again, slope depends on inclination of the line. Slope depends on inclination of the line. So this is the definition of slope. So let me write clear definition once to define slope of a straight line. So definition of slope of a line. Slope of a line. If a line whose inclination is theta, then tan of theta is called, tangent of the inclination, tan theta is called slope of the line. Slope of the line. And slope of a line is always denoted by m, and slope of a line has no units. So you cannot give any units to the slope of a line, purely because tangent of an angle is a purely real number. Therefore it is a scalar quantity. It has simply a scalar quantity. It has no units. So dear students, once again I'll just preview the concept what all we have discussed so far simply. First, angle of inclination of a line. A line makes an angle theta with the positive x-axis measured in positive direction, lies in the interval 0 to 180 degrees, is called inclination of the line. If you know the inclination of the line, to find out slope of a line, tangent of the inclination gives the slope of the line. Our slope is also called as gradient of the line. So let us discuss some simple examples and small basic things how to find out slopes of a lines, different lines. So here once again let us start with this simple example. Here this x-axis, y-axis and origin, a line whose inclination is 30 degrees, to find out slope, the slope is equal to tan 30 degrees. Therefore, slope is equal to, that is m is equal to 1 by root 3. Slope of a line, if a line makes an angle, or if a line whose inclination is 30 degrees, then the slope can be defined as tangent of the inclination. That is, here the inclination is 30 degrees. Therefore, tan 30 is equal to 1 by root 3. Similarly, some more examples in the different forms we can define how to find out the slope of a straight line. So, small diagram point of view, the simple examples I am going to give you how to find out slope of a line. If a line whose inclination is 45 degrees, then the slope of this is tan of 45, that will be equal to 1. And similarly, we can go for this x-axis and y-axis and origin. If a line whose inclination is 60 degrees, then slope is equal to tan 60 degrees. Therefore, m is equal to root 3. But here, on the small, just additional point you try to understand, if this vertex of this angle, this is the point is called vertex of this angle, if this vertex is coincide with the origin, then this angle is also said to be in standard position. Most of the trigonometric functions, we keep the angles in the standard position. But whereas in the geometry, just we consider angle of the line with the positive x-axis to define slope of a line. So, if the inclination is 30 degrees, slope is 1 by root 3. If the inclination is 45 degrees, the slope is 1. If the inclination is 60 degrees, the slope is root 3. Here clearly we can observe, clearly we can understand that if the inclinations are acute angle, so here one must be able to understand what is acute angle? Angle which is above 0, below, less than 90 degrees. If the inclination is acute angle, then the slope is clearly positive. Here the slope is always positive. This is the one simple note, you just make it. Then automatically, since the inclination we have a chance to use the inclination up to 180 degrees. Therefore, the inclination may come in also in second quadrant up to 180 degrees, that is in tan. As very simple, we know that in second quadrant tan is negative, and clearly if the inclination is positive, if the inclination is acute angle, then slope is positive. If the inclination is obtuse angle, then the slope is negative. So how we can define how to find out slope of a line if the inclination is obtuse angle. So before going to take up this obtuse angle, now let us once again consider two simple things. As we know that every straight line has slope, then x-axis and y-axis are also lines, then they must have slopes. How to find out slope of x-axis? So today we'll discuss about slope of x-axis. Let us complete first, and similarly we'll discuss about slope of y-axis. That we'll see what happens slope of x-axis and slope of y-axis. Here, look at the simple fundamental here, x-axis, y-axis and origin. So clearly, as we know that a line whose inclination is theta, then the slope is what? Tan of theta. This is the basic definition. We are aware of this definition also. But if this line just gradually, if it is reduces the angle theta, then when this line coincides with x-axis, angle theta becomes 0. Please once again try to understand. If this line just coincides with x-axis, then the angle theta becomes 0. So when the line becomes x-axis, therefore slope of x-axis will be tan of 0. Therefore tan 0 is 0. Dear students, always remember slope of x-axis is always 0. Or also inclination of any horizontal lines will be taken as always 0 degrees. Since horizontal line's inclination is 0, then definitely slope will be tangent of inclination. Tan 0 is equal to 0. So x-axis, slope of x-axis is always 0. And here one more point all the students has to remember, slope of a line does not depend on size, or that is length of the line. Slope of a line always depends on inclination of the line, not on the size of the line. So similarly, now we discuss about slope of y-axis now. So let me here write this. So this is x-axis, sorry, this is y-axis and this is x-axis. This is y-axis and this is x-axis and origin. Clearly, just observe this. Here y-axis is the line whose inclination is theta degrees. Whose inclination is directly 90 degrees, right? Once again, try to understand this. Here y-axis is the line whose inclination is 90 degrees. So then to define slope, so tan of 90 degrees, as we know that tan 90 degrees is infinity, or it's called not defined. Actually, speaking in real terms, this vertical line will be called as perpendicular, not slope. Slope means, usually in general meaning, slope means a line should be somewhat inclined. It is oblique. But here, the slope of y-axis is not defined. Slope of y-axis, because y-axis whose inclination is 90 degrees. In order to the definition of slope of any line is tan of inclination, but for y-axis here inclination is 90 degrees. Therefore, tan 90 degrees is not defined, it's infinity. So these two things you try to understand. So once again, for your reference, I'm going to give the simple x-axis slope is always 0 and y-axis slope is always not defined or infinity. You can also write not defined. Here later on, we'll have one more discussion for two slopes of two perpendicular lines. That time we'll clear about this. This product of these two lines must be equal to -1. So later on stages we'll try to clear this point. So this is the fundamental basics. You remember it. Before defining any slope of a line, one should have clear idea about inclination of the line. But inclination is the angle of a line with the positive x-axis measured in positive direction. It is always lies in the interval 0 to 180 degrees. And always inclination of any horizontal lines will be taken as 0, since x-axis is a horizontal line. Therefore, his inclination I have taken it as 0. Therefore, slope is equal to tan of 0. Here y-axis is a line whose inclination is 90 degrees. Therefore, slope of this line is equal to tan of 90 degrees, which is not defined. Dear students, I hope you understood the basics, fundamental definition of slope of a line. Now let us move on to slopes of parallel and perpendicular lines. So let's start with slopes of parallel lines. Okay, slopes of parallel lines. Here, slopes of parallel lines. Slopes of parallel lines. This is one of the important idea all the students should know about before handling the different types of lines, slopes of parallel lines, slopes of perpendicular lines, how they will be, and what is the condition for perpendicularity and the condition for parallel lines also. So let us start with this. So let us simple is think that my both hands I kept on horizontal line. This is the horizontal line, both hands. As clear you are observing that these two lines are parallel. Definitely if I tilt these two lines, then definitely the inclinations are what? Same. So if this inclinations of both the lines are same, suppose if this inclination is theta, then definitely this inclination is also what? Theta. Therefore, the slope of first line is tan theta, second line slope is also tan theta. Clearly we understand, clearly we observe that if the two lines are parallel, then their slopes are always equal. So once again note down this, if the two lines are parallel, then their slopes are always equal. Suppose if M1 and M2 are the slopes of the lines. These lines will be parallel only if M1 and M2 are equal, that is M1 is equal to M2. So let us simply the small diagram, I will try to explain this, how to find out slopes of parallel lines. So here thing is, let us take two parallel lines, line 1 and line 2. So this is the line 1 and here this is line 2. So these two lines are parallel. So this is line 1 and this is line 2. Suppose if inclination of line 1 is theta, definitely inclination of line 2 must be also theta, because as they are parallel lines. I told you, both the hands I kept on horizontal line, then definitely if they are parallel, their inclinations will be same. So clearly the slope of first line M is equal to tan theta. So to avoid confusion, we take first line slope is M1, and the slope of second line M2 is equal to tan theta, and therefore clearly we are observing M1 is equal to M2. M1 is equal to M2. So just make a small note here. Clearly once again I'll explain this part. If the two lines are parallel, then their slopes are always equal. That is, if M1 and M2 are the slopes of the lines, these lines will be parallel only if M1 is equal to M2. Only if M1 is equal to M2. I hope you just cleared the concept of slopes of parallel lines. So any two parallel lines, definitely their slopes will be equal. Or conversely, if the slopes are equal, then definitely lines must be parallel. So now let us discuss some more items like. So here, once again, I'll get back to the point of slopes only. Look at. Clearly we came to know this. We came to know that x-axis slope is always what? 0. X-axis slope is always 0. Then now the question arises, if any line, if all the lines, some lines are parallel to x-axis. Suppose if the lines are parallel to x-axis, then definitely we have discussed about if the lines are parallel, then their slopes are what? Equal. Then definitely for all lines the slope will be 0. For all the parallel lines, x-axis, for all the lines which are parallel to x-axis, whose slopes are always 0. So try to understand, just remember this, make a note here. Slope of any line parallel to x-axis will be taken as always 0. Slope of any line parallel to x-axis will be taken as 0. Now we'll discuss about once again another condition here, like. So again, for y-axis, this is x-axis and this is y-axis, origin. You know that for y-axis the slope is not defined, infinity, then definitely any line parallel to y-axis, means perpendicular to x-axis also we can take. Again the same condition I'll use, if the lines are parallel then their slopes are equal. Here y-axis slope is infinity, means definitely these all slopes will be infinity, that is not defined. The slope of this line is not defined. So again, here also make a simple note. Any line parallel to y-axis whose slope is always not defined. Or take m is equal to, slope is equal to infinity for any line which is parallel to y-axis. Hope you understood, you have just cleared the concepts of parallel slope, inclination, slope and slopes of x-axis, y-axis and parallel lines. Dear students, let us discuss about slopes of perpendicular lines. It's the most important concept. Once again, how to define, how to define slopes of perpendicular lines and what are the conditions for two lines to be perpendicular. So, slopes of perpendicular lines. Slopes of perpendicular lines. Perpendicular slopes of perpendicular lines. So let us, but before discussing slopes of perpendicular lines, the condition, the definition, whatever I am going to discuss will be applicable for all the perpendicular lines except the lines which are horizontal and vertical, because vertical line slopes are not defined. So that clearly the concept which we are discussing about perpendicular lines, two lines, we cannot consider two lines perpendicular like horizontal and vertical. This cannot be considered in our discussion. You are free to take any perpendicular lines other than horizontal and vertical lines, and two lines cannot be perpendicular to each other where the one line is horizontal and another line is perpendicular. So let us now discuss. So clearly, first let me complete the statement now. Suppose this is the one straight line and this is the another straight line. Sure, they are not parallel, both the lines are not parallel and vertical, and that means both the lines, any one line is not parallel to x-axis and other line is not parallel to y-axis. So these are two perpendicular lines I have taken. If the two perpendicular lines, suppose this is the line 1 slope is m and line 2 slope is m2. If the two lines are perpendicular, then their product is always equal to -1. That is, this is the condition. Let us prove it. m1 into m2 is equal to -1. Dear students, once again, now I'll give the statement, simple statement first. If the two lines are perpendicular, then the product of their slopes is always equal to -1. Suppose product of the slopes is not equal to -1, it's very clear that two lines are not perpendicular. Finally, in later stage, definitely we'll make this one is a condition for two lines to be perpendicular. Here once again, let me explain. If the two lines are perpendicular, then the product of their slopes is always equal to -1, except the lines which are horizontal and vertical. Why? Because if any line is vertical, that is perpendicular to x-axis or perpendicular to horizontal, where its slope is not defined, you cannot multiply and prove that the product is -1. Or indirectly we can say that some of the teachers, they may ask you x-axis slope is as, because according to this definition, and the slopes are, if the two lines are perpendicular, then the product of their slopes is equal to -1. Then some teachers will ask x-axis slope is 0 and y-axis slope is infinity, multiply and prove it -1. No, this is not applicable, and this is applicable, or indirectly strictly this is applicable wherever the slopes of two lines are properly defined. But in this case, y-axis slope is not defined. Therefore, this condition will not work out for x-axis and y-axis or any lines which are parallel to x-axis and parallel to y-axis, which are perpendicular to each other. Let us now. So let me complete this. Once again, before going to start through this simple condition, let me explain this part. If the two lines are perpendicular, then the product of their slopes is always equal to -1. If the two lines are perpendicular, then the product of their slopes is always equal to -1. So let us start with this simple derivation. I will just start with simple derivation now. So consider this is y-axis and this is x-axis, y-axis. So let us take first, this is the line AB, this line AB, this line AB. So assume that whose inclination is theta, and take one more line, this is CD line, this is CD, which is clearly, this diagram is not up to the scale clearly. This is perpendicular, you think that this is perpendicular to each, this is the line is CD. So this is 90 degrees. So first, this AB line and CD line are perpendicular to each other, but see that these two lines cannot be horizontal and vertical. Here, yes, AB and CD lines are perpendicular to each other, and let assume that angle line AB, the line AB whose inclination is theta, and as we know that in any triangle the sum of two interior angles is always equal to exterior angle. This will be what? 90 degrees plus theta. Please try to understand. Here, consider two perpendicular lines AB and CD, where AB and CD are perpendicular to each other as shown in the diagram. But here, let us take theta be the inclination of the line AB. Inclination means you are aware that a line of the line, angle of the line with the positive x-axis measured in positive direction between the interval 0 to 180. As these two lines are perpendicular, here it is 90 degrees. Then as in any triangle, the sum of the two interior angles is always equal to exterior. Dear students, once again here clearly observe that the AB inclination is theta. If you take AB inclination is theta, then automatically the inclination of the line CD will be 90 degrees plus theta. Okay. First assume that slope of AB will consider as M1 and slope of CD is considered as M2. Definitely it's our duty to find out. First you find out M1 and find out M2, and after that multiply them, and you have to show that their product is equal to -1, because here the two lines AB and CD are perpendicular to each other. Dear students, once again let us start now. Let M1 be the slope of line AB, and clearly from diagram M1 is equal to tan theta, and yes, M2 be the slope of line CD. Here clearly we have considered two perpendicular lines. We have to find out M1 and we have to find out M2, and it's our duty to show that M1 into M2 is equal to -1 because they are perpendicular lines. If the two lines are perpendicular, again I am repeating, if the two lines are perpendicular, then the product of their slopes is always equal to -1. Okay. So M2 be the slope of the line CD. So what is M2 now? So M2 is equal to slope of CD. Slope of CD is equal to tan 90 degrees plus theta. But it is already, we know that tan 90 plus theta is equal to minus cot theta, as allied angles 90 plus theta comes in second quadrant, tan is negative. So now we have to multiply. M1 into M2 is equal to, what is M1 here? Tan theta into minus cot theta. But here tan theta into minus, tan theta can be written as 1 by cot theta can be written as 1 by tan theta by using reciprocal relation, and tan theta gets cancelled. This will be equal to -1. Therefore M1 into M2 is equal to -1. Dear students, make a note here once again. Clearly, if it is very clearly, I'll explain. So please make a small note here. If the two lines are perpendicular, then the product of their slopes is always equal to -1. This condition is applicable only for the lines, or it is applicable except lines which are horizontal and vertical. So here clearly we have taken two perpendicular lines AB and CD. First line slope is clearly, it shows the tan theta. Second line slope is tan 90 plus theta. We know that tan 90 plus theta is equal to minus cot theta, and M1 is equal to tan theta, M2 is equal to minus cot theta. Therefore their product tan theta into minus cot theta, tan theta into cot theta can be written as 1 by tan theta. Tan theta gets cancelled, -1. So again, if the small note here, if M1 and M2 are the slopes of the lines, these lines will be perpendicular only if M1 into M2 is equal to -1, and conversely, if M1 into M2, the product of the slopes of two lines are is equal to -1, then definitely two lines are perpendicular to each other. Hope this is the one basic fundamentals of slope of a line. Let me just discuss with small example with you how to find out slope of a line. Hope once again I'll review the things what all we have discussed now. Before defining slope, we must know inclination of the line. So clearly in short terms, a fast review, inclination is the angle of a line with the positive x-axis measured in positive direction lies in the interval 0 to 180 degrees. In the diagram I've given the interval properly. So 0 I put square bracket and 180 degrees is small bracket. I think you will be learning open interval, closed interval, half open, half intervals in the first chapter of your syllabus. If theta is the inclination, simply directly slope is equal to tangent of inclination. And if the inclination is acute angle, then definitely slope is positive. If the inclination is obtuse angle, that slope is negative. Since all horizontal lines whose inclination will be always 0 degrees, therefore x-axis is a line, x-axis is also a line which is horizontal, therefore its slope can be calculated by tan 0, therefore tan 0 is equal to 0. Y-axis whose inclination will be 90 degrees, therefore tan 90 degrees is equal to infinity or not defined. Slope of y-axis is not defined. Slopes of all the lines parallel to x-axis will be taken as 0. Slopes of all the lines which are parallel to y-axis slopes of y-axis, slopes of all the lines parallel to y-axis is always not defined. And if the, again comes to the point, slopes of parallel lines, if the two lines are parallel, then their slopes are equal. If the two lines are perpendicular other than x-axis and y-axis or other than any perpendicular lines which are horizontal and vertical, then the product of their slopes is always equal to -1. So let me just solve a small example, couple of examples for you. Look at this. Find the slope of the line whose inclination, find the slope of the line whose inclination is 150 degrees. Whose inclination is same. So very directly, m is equal to tan of 150 degrees. As we know the definition of slope, what? If you know the inclination, put directly tan of inclination gives the slope. So tan, and you can go 90 plus 60 or yes, as usual you can go for it 90 plus 60. That will be minus cot 60 minus 1 by root 3. Minus 1 by root 3. So here 90 plus 60 we can write 1 is 90 is 1 times of 90 odd number, and further in trigonometry also you'll study these allied angles or related angles, you'll be studying this. Therefore cot 60, tan 60 we know that root 3, therefore cot 60 will be 1 by root 3. 90 plus 60 comes in second quadrant, tan is negative. Therefore. So another example. So let us, so sometimes you'll ask the questions like this. Find the equation of the line, find the slope of the line, which makes an angle 225 degrees with the positive x-axis. Dear friends, there's a small change in this problem. Please read the question once again properly. Find the slope of the line which makes an angle 225 degrees with the positive x-axis. Here most of the students they commit, of course sometimes you may get the value, but you have to work with properly. 225 degrees cannot be called as inclination. Of course 225 degree comes in third quadrant, there will not be any change in the value, but that's not right. So to solve this problem, first what is inclination? Always we are clear that inclination is the angle lies between 0 and 180 degrees. Okay. So this is the diagram, how we can take now. X-axis, y-axis. So 0 and 180 plus 45, that is 225 degrees it comes here. This is 225 degrees. This is 225 degrees. That means this angle will be only the magnitude of this angle is 45 degrees because 180. So it will be like this 0, 90, 180 and plus 45. If I extend this line further in this case, definitely if this is 45 degrees, then definitely this will be 45. Now clearly it shows that since whenever the line makes an angle 225 degrees with the positive x-axis, the inclination will be 45 degrees. Observe this. Inclination means what? We always take inclination of the angle must be within the range what? 0 to 180. 225 degrees cannot be taken. Of course, mathematically if you solve both the tan of 225 and tan 45 both gives the same value. But you have to solve it in traditional way. You cannot move out of this inclination definition. So if the line, here it is, clearly it is making 225 degrees means this is the quantity is 45 degrees. Then definitely this will be 45 degrees. So please, in this example, please try to understand. If a line makes an angle 225 degrees with the positive x-axis, then definitely inclination of this line will be 45 degrees. Now, so here the solution is, so inclination that is theta is equal to 45 degrees only. Now slope is equal to tan 45 which is equal to. So clearly once again, even in trigonometry point of view, tan 225 also gives 1 only. But you cannot use the angle which is greater than 180 degrees as an inclination. Hope you understand this problem. Once again, in this example particular, so first one is 150 degrees. Directly we can take it as inclination, therefore I have taken tan of 150. But if a line makes an angle 225 degrees, that time if you draw the systematic diagram, definitely the inclination of the line will become 45 degrees. So therefore slope of the line is taken as tan 45, therefore tan 45 is equal to 1. Again you remember that slope has purely a real number, it has no units. Slope of a line has no units. And remember, slope of a line always depends on inclination, slope never depends on the size of the line, that is length of the line. Thank you dear students. In the next class, we'll be discussing about slope of a line joining 2 points and the problems based on that. Then we'll go for equations of straight lines.